I'm Garrett Burton, and this presentation is on the emergence of Yellowstone cutthroat trout. So my wife and I, we love to fish, and this is a picture of my wife with Yellowstone cutthroat trout. And this is why I chose this topic. So this presentation will include a description of Yellowstone cutthroat trout's characteristics, a description of their geographic distribution, a timeline for their evolution, and two hypotheses of regarding the divergence of the Yellowstone cutthroat trout. It also will briefly highlight some threats to sustainable populations. So characteristics of the Yellowstone cutthroat: they're aggressive feeders. Phenotypically, they're a dull yellowish brown, sometimes an olive brown color. They have a red patch on their cheek, which can extend down their the lower part of their side, and they have an orange slash under their jaw. Their spots increase in density as you go towards the tail. This slide just highlights some variability within the species. You'll see the one on the left has a more red gill plate and more spots, and you'll see the one on the right, you can see the orange slash under its jaw. They all have that, but that one you can see it. The geographic distribution of cutthroat trout, it varies a lot. There's a lot of different subspecies of cutthroat. There's several different clades, and they're distributed in different places from Alaska almost all the way down to Mexico. But the Yellowstone cutthroat trout specifically is found in the Snake River above Shoshone Falls. So on this map, that would be down by the left hand, the bottom left. And they're also found, and they're in the Snake River and all of its tributaries above there. And they're also in the headwaters of the Yellowstone and Bighorn rivers and tributaries associated with them as well. So salmon and trout, members of this family, actually this order, it's the Salmoniformes order. They're only found in waters draining to the Pacific Ocean. Natively, they are found in waters draining to the Pacific Ocean. You'll notice the Yellowstone and Bighorn rivers actually drain to the Atlantic Ocean, so they're on the eastern side of the continental divide. But historically, all members of this order originated on the Pacific side. So the earliest fossil evidence for relatives of the cutthroat trout, this fossil is called Eosalmo driftwoodensis, was found in British Columbia, and other fossils like this have been found in northern Idaho and Washington. This was dated back to 50 million years ago, and this represents a primal form of the Salmoniformes order. So fossil evidence is kind of sporadic, and the next fossil mentioned that's related was named Hucho, which is actually a part of the same family as trout, but it's in a different genus. And it dated back to 20 million years, and I couldn't find any images of that. And these are just some other images of fossils from salmon, which are in the same family as trout. These date back to 7 million years. And by 7 million years, it was clear from the fossil record that divergence was well underway. Different species of salmon, like pink salmon, chum salmon, and others are shown in the fossil record. And so we can assume that if these species that are in the same family have diverged, some of the other trout species have probably diverged as well by 7 million years ago, just based on fossil evidence. So this is a karyotype of a Yellowstone cutthroat trout. Yellowstone cutthroat trout have 64 chromosomes. So old fish species, like fish species that haven't really changed much in a long, long time, generally have 48 chromosomes. So the idea is that a tetraploid event occurred at some point millions of years ago in an ancestor to the trout and salmon family, and doubling. So a tetraploid event would double that number from 48 to 96, and then Robertsonian fissions have been occurring over millions of years, which would reduce the chromosome number down to what we have today. And so a Robertsonian fission is where two different chromosomes fuse, and this generally happens at the centromere, and it happens more easily with acrocentric chromosomes, so they have a centromere on the end, and fish, especially the older fish species, have more chromosomes with the centromere at the end. So this idea that a tetraploid event could have occurred, helping the evolution of the species along, of the genus along, I guess. It makes a lot of sense. Let's see. So if the original chromosome number of 48 was doubled, and over millions and millions of years, it has been gradually reducing with these Robertsonian fissions. Trout and salmon species with more chromosomes would represent a like an earlier like the divergence occurred earlier. So there's three different chromosome numbers in different cutthroat trout subspecies. For example, the coastal cutthroat trout, which represents the most primitive species of cutthroat trout, has 68 chromosomes, and the Yellowstone cutthroat trout has 64 chromosomes. And there's one in the middle. The West Slope cutthroat trout actually has 66 chromosomes. Okay. So there's two. Let me back up a little bit. Actually, the second paragraph here talks about DNA analysis for the different clades of cutthroat trout differing. So there's 4 different clades of cutthroat trout, and the rainbow trout, which is a different species, is thought to be what cutthroat trout diverged from. And DNA analysis shows that these different clades of cutthroat trout are as different from each other as they are from the rainbow trout, which would be like the parent species. So from this, we can assume that divergence from rainbow trout and divergence from each other, the different cutthroat trout species, began at roughly the same time. And other analysis of DNA suggests that this divergence event, this speciation event, occurred between 8.3 and 3.5 million years ago. So one of the hypotheses regarding the divergence of the species has to do with an inland dispersal. So the idea, and the first one, the inland dispersal hypothesis, is more generally accepted. It involves a common ancestor evolving in the Pacific Ocean, and this is supported by more of the fossil evidence. All the fossil evidence of the salmoniforms or salmonid family is in the Pacific Ocean, from both in North America and also in Asia, but just in the Pacific Ocean north of the equator. So the idea is that as inland migration of this species, of this ancestor occurred, as migration occurred up different drainages, up different river systems, that would provide the isolation mechanisms necessary for divergence. So I can't really show you on this map very well. I tried to figure out how to draw as we talked, but there's several different river systems that drain through the Columbia River system, which this is a map of the Columbia River drainage basin. And there's a river called the Clearwater River and the Salmon River and there's also the Snake River. And the Clearwater and Salmon River have the West Slope cutthroat trout, and the Snake River has the Yellowstone cutthroat trout. So, as maybe a common ancestor of these migrated up adjacent drainages, this isolation could have provided the, this isolation could have caused speciation or divergence from the same species. These West Slope cutthroat trout and Yellowstone cutthroat trout are actually the same species, though there are some significant differences. So another hypothesis is that this evolution of the cutthroat trout occurred in an inland body of water, and this isn't supported by as much fossil evidence, but the same mechanisms of divergence through isolation as they migrated up different drainages can still be applied. The idea is that Lake Idaho, which existed from about 16 million years ago to about 1 million years ago, was home to a common ancestor, and the divergence occurred, and now we have the cutthroat trout species that we have today. And again, this hypothesis isn't as widely accepted. So we can conclude that the inland dispersal method or hypothesis is probably more correct in explaining the emergence of the Yellowstone cutthroat trout. So just briefly, a few threats to the sustainable population of cutthroat trout now include predation, hybridization, and competition. The figure on the left is a lake trout that was taken from Yellowstone Lake. Yellowstone Lake is home to the largest population of Yellowstone cutthroat trout. And lake trout were introduced in the 70s. And it was projected that they could have a really significant impact on the Yellowstone cutthroat trout. But gill netting and management has slowed the lake trout's population growth. And the population of cutthroat trout is very sustainable. Another threat, the biggest threat actually, is hybridization. So cutthroat trout can hybridize with rainbow trout. It appears that as they were isolated and they evolved, they didn't evolve isolation mechanisms for reproduction. So as rainbow trout and cutthroat trout are in the same waters, they will hybridize, and this it creates unpure cutthroat trout genes. And rainbow trout tend to outcompete cutthroat trout in a lot of situations as well. And the last one, competition between species. This often occurs in waters where brook trout and cutthroat trout coexist or brook trout are introduced. Brook trout tend to outcompete cutthroat trout as well. And this is thought to be because cutthroat trout evolved as the only trout in the waters in which they evolved. So they didn't evolve any like defense mechanisms for this. So brook trout, they actually spawn in the fall, and cutthroat trout spawn in the spring. And it's thought that the juveniles and the fry are where competition is most influential, I guess. So yeah, these are just several threats to sustainable populations. And that is what I learned about the emergence of Yellowstone cutthroat trout.